Good morning, class. So in this live lesson recording today, we're going to be going over Unit 7, Lesson 9, which is comparing the volume of cones, cylinders, and spheres. So they have a special relationship, which we'll talk about in this lesson when you compare like a cone and a cylinder, for instance. And one of the things, like what you'll notice here is if you look at these formulas, so I should use my draw tool. So if you look at this formula and this formula, notice that the only difference in a cone and a cylinder is that a cone has this 1/3 out front. So if you have a cone and a cylinder that are the exact same height and the same radius, then the only difference between the two is a cone has 1/3 of the volume. Okay, so that is kind of the relationship there. And then notice here that also in the sphere, so these are the traditional formulas that we used in the lessons earlier. But notice here that this is the same formula, pi r, except here it's squared, here it's to the third. So if we just change this height to the same thing as the radius, so if the height of the cone or the cylinder is the same as the radius, then really the only difference here is this 4/3 out front. But here, notice that they're using the diameter as the height. So if the diameter of the sphere is the same as the height of the cone or the height of the cylinder, then we have this situation down here. So this is a very, very specific circumstance. But if you have a circumstance where all the radiuses are the same, so the radius of a sphere is the same as the radius of the cone, which is the same as the radius of the cylinder, then also the heights have to be the same. So the height of the cylinder, the height of the cone, and the diameter of the sphere all has to be the same. Then this situation works. Okay. And what you'll notice about this situation is if you take a cylinder, this is the relationship here. It says the volume of a cone is 1/3 the volume of a cylinder. So we already kind of talked about that, right? If you take the volume of a cylinder, multiply it by 1/3, you get the volume of a cone. The volume of a sphere is 2/3 the volume of a cylinder. Again, that's only if the radius and the height are the same, or the diameter of the sphere. Then it's 2/3 the volume of a cylinder. So if you knew the volume of the cylinder is like, let's say 12, to find the volume of the sphere with the same radius and same height, or same diameter, then you would just multiply it by 2/3 to find it. And then this other one is the volume of a sphere is twice the volume of a cone. So if I know that the volume of a cone is 12 and the radius is the same, so they both have the same radius and they both have this height is the same as the diameter of the sphere, then I know that this sphere would have to have a volume of 24 whatever units cubed, because it's exactly twice the amount. So that is like a special relationship that they have. So we'll go through some questions where we utilize these formulas. So true or false, a cone is equal to a cylinder minus a sphere. So if you take the volume of a cylinder, so we're using this formula and this formula, does that equal the same thing as this piece here? So in other words, here we have, so if you look at the cylinder, it's 2 pi r to the third. Okay, so that's really like 6/3. So remember, if you want to do, by the way, this exact formula is actually in the lesson. So what I'm showing you here, you don't even need to know, but I'm just showing you why it's true. And if I subtract 4/3, which is the volume of a sphere, right? So all I'm doing is I turn 2 to 6/3, right? Because 6/3 is 2. So I have a common denominator. The volume of a sphere is this 4/3. So 6/3 minus 4/3 equals 2/3. And if you look at the volume of a cone, it's 2/3. So that is true. By the way, this exact thing is written in the lesson. So a cone is equal to a cylinder minus a sphere. That is true only if we have that special circumstance that we were talking about, where the radius is the same of all three, and the height of the cone is the same as the height of the cylinder, which is the same as the diameter of a sphere. Very special circumstance. All right, so it says the volume of a cylinder is 36 centimeters cubed. What is the volume of a sphere if its radius is the same and has cylinder's height equal to the cylinder? Okay, so that's that special circumstance we were just talking about. Okay, so the volume of a cylinder is 36. So now we just need to look at the relationship between volume of a cylinder and the volume of a sphere. So up here, it says that the volume of a sphere is 2/3 the volume of a cylinder. So if I take 36 and multiply it by 2/3, then I get the volume of a sphere. So in this case, I'm just going to go to Desmos. Times 2. Get my face out of the way there. 2 divided by 3. I don't know if you guys can see that. And that's 24. So 36 times 2/3 is 24. So that would be 24 cubic centimeters. All right. This one says the volume of a cone is 25 times pi, 25 over 3 pi centimeters cubed. What is the volume of a sphere if its radius is the same and the cone and the height is the same as equal to the... Okay, so this is that... It's just going to keep giving that special circumstance where the radius is the same and the cone's height is the same as the sphere's diameter. Okay, so again, we're just looking at the relationship between a cone and a sphere. Okay, so if we look at the cone and the sphere, it says the volume of a sphere is twice the volume of a cone. So I just need to multiply this number by 2. So 25 over 3 pi. So 25 over 3 pi times 2. Okay, so then that's just going to be 2 times 25 is 50 over 3 pi centimeters cubed. So really this is like 2 over 1 and you just multiply across. So 2 times 25 is 50. 1 times 3 is 3. And that's it. All right. This one says, a sculptor created a design by carving a cone out of a cylinder. Okay, so imagine that this is like a cylinder and you carve out this cone shape out of it, this yellow part. You're carving that out of the cylinder. And they share the same radius and height. If the volume of the cone before removing is 54 inches cubed, what is the volume of the amount remaining? Okay, so basically in this case, you're taking away 1/3 of the, so like if you look at the relationship between a cylinder and a cone, the volume of a cone is 1/3. So what's remaining is still 2/3. So if I basically have 1 and I'm taking away 1/3, I'm left with 2/3 of the volume. So 2/3 of the original volume is still remaining. So that would be 54 times 2/3 to figure out what the remaining volume is. So let's see. Might be able to do this in my head. I think it's 36, but we'll just double check with Desmos. All I'm going to do is I'm going to come back here and I'm going to change this to, oh, okay, never mind. I'm not going to do that. 54 times 2 over 3 is 36. So 36 inches cubed. Now, what you could do is you could have done 54 times 1/3, and that would tell you how much to subtract from 54. So that would also work. So then what I would get there is I'd get 18 inches cubed, and then I'd have to take that 18 inches and subtract it from 54. So 54 minus 18 equals 36. So either way, you're going to get 36 cubic inches. It's just a matter of how you get there. All right, and last but not least, it says an engineer wants to know the volume of an following object composed of a hemisphere and a cone. So you got essentially half a circle plus the cone. She knows the height of the cone is equal to the diameter of the hemisphere, so that's that special circumstance again. And the volume of the cone is 12. Okay, so the volume of the cone is 12. What is the volume of the whole object? Okay, so we need to look at the relationship between the volume of a cone and a sphere. Okay, so the relationship between the volume of a cone and a sphere is that the circle, or the sphere, is twice the volume of a cone. But we only have half of that, right? So if this were a whole circle, the volume would be 24, but we only have half of that. So we want to take away half of it, so divide by 2, And so the volume of that hemisphere is also 12. So 12 plus 12. So the volume of the cone is 12. The volume of the hemisphere is 12. So 12 plus 12 is 24 meters cubed. And that is it for that lesson. So really, the part that you really have to focus on is just these three things, this relationship. So what is the relationship of a volume of a cone to the volume of a sphere? What is the relationship between the volume of a sphere to the volume of a cylinder? And volume of a cone to volume of a cylinder. So this piece right here, this little triangle that shows the relationship between the three, is the most important part of this unit, or of this lesson. It's really a special circumstance. There's not like a circumstance where that's going to be like commonly used, but it is something that it's a relationship that they want to make you aware of in the lesson. So anyways, that is it for lesson 9. If you guys have any questions after this lesson, the only thing we have left in this unit, if I can move my stuff out of the way here, is coming here. We have our sample work, which is dropped. So if you go in there, you'll see that it's been dropped. And then after that is the practice test and then the test. So we do have the test coming up relatively soon next week. So if you guys have any questions, feel free to reach out. Otherwise, have a fantastic rest of your day.